Hello, I'm back. Yes, I would like to explain about what we did in the lecture on example number 3, which is on page 16 of your lecture notes. If you recall, we have a question of an operational amplifier, okay, with this circuit as shown. Now you were asked to determine which of the LEDs that will turn on. Is it LED 1, LED 2, LED 3 or LED 4? And what you should first of all realize is that on the left hand side over here you have a series of resistance. Okay, there are altogether 5 resistance in total, right? Each of them are 1 kilo ohm. Now the important thing here is to determine what is the voltage on each of this point here. If I may call it V1, V2, V3 and V4. Now it is important to know what these voltage at each of these points are, because we are using the op-amp as a comparator. We will be comparing the voltage on the V plus, okay, with the voltage at this point. So first of all, in order to solve this question, you need to calculate what is the total resistance on this series line over here. Now it is quite simple, because there are a total of 5 resistance RT, which is equals to 1K times 5 or 5K, 5 kilo ohm, right? Now after having find that, we can either use the voltage divider to find what is the voltage at V1, at V2, at V3 and V4. Another way to do it is to find what is the total current that is flowing over here in this series resistance, ignoring the operational amplifier for the time being. Okay, find out what is the current that is flowing through here. Okay, so we can determine that by using I equals to 6 volt divided by 5 kilo ohm, which gives me 6 divided by 5 to the power 3 will give me 1.2 milliamp. Alright, then we can determine what is the voltage at V1, which is simply V1 is equals to 1.2 milliamp times the resistance, which is 1 kilo ohm, which gives me 1.2 volts, right? So that's for V1. Now V2, similarly, we will do the same. Remember, we are going back to the basics of V equals to IR. Okay, so similarly you can determine what is V2, which is 2.4 volts, V3, which is 3.6 volt, and V4, if you work it out, it will be 4.8 volts. Okay, now having done that, okay, we will be required to explain which LED will light up, given that the Vin, which is the voltage at the non-inverting terminal, which is the V plus over here, 2.8 volts. Now it's very clear that 2.8 volts as compared to 1.2 volt, which is V1, the output will be plus V set, right? So it is a positive voltage and we are able to turn on the LED 1. So this is good. Similarly, for when your V plus here is at 2.8 volts, it is greater than 2.4 volts. So this will be a positive V set, and hence this will turn on. Now when it comes to this point here, now V plus is 2.8 and over here your V3 is 3.6 volt. Now this is smaller than this voltage over here, and therefore this cannot turn on. And that goes to the same for this. Your V in is 2.8 volts, and this negative point here, the terminal V4, is 4.8. So this cannot turn on as well. Alright, so now what happens in the question when V in equals to 0? So when V in is equals to 0, none of this will be able to turn on. Now, and the last part of the question here is to calculate a suitable value of the resistance RS. Okay, if the LEDs have an operating parameters of 2.4 volts at the current of 10 milliampere. Now it's quite simple over here, because we know that the output saturation voltage is given over here. V set is at plus 11 volts. That's given to you, right? Now, using this bit of information here, we can say that if the op amp is turned on, we can calculate this what do you call that, using the Kirchhoff voltage law over here to calculate what is the actual resistance that flows over here. Now, in order to do that, it's quite simple. I may just draw a plus 11 volt here, okay, with the resistor RS, okay, and followed by this LED. Correct. Now this LED has a forward voltage of 2.4 volts, right? So what I'm going to do is that I will take 11 volt minus away the voltage 2.4 to give me the voltage drop across the RS. And then, okay, so which means a little bit tight on space here. So the RS, okay, in short, will be equals to 11 minus 2.4 volts divided by the current, which is given as 10 milliampere, right? So what you will end up is, okay, 8.6 voltage at the top divided by 10 milliampere, which gives us 860 ohm resistor. That's all for now.